Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is smart pointers having a cycle of ownership. Before proceeding, make sure that you have already watched these other videos first. Consider implementing your own linked list data structure, where each linked pointer is implemented using a shared pointer. If that data structure forms a cycle, then none of the nodes in that cycle would ever get destroyed, because each cycle node has some other cycle node that justifies its existence. To solve that cycle of ownership problem, a weak pointer provides aliased access to the same payload as some particular shared pointer, but without increasing that shared pointer's reference count. This weak pointer is just another way to access this shared pointer's same payload. So you could query that payload's reference count through either object. Notice how the existence of the weak pointer has not contributed to that reference count. A weak pointer is always defined in terms of some other shared pointer. That defining could be transitive, defining this weak pointer in terms of another weak pointer, which itself had been in terms of the shared pointer. To access a payload through a weak pointer, you need to first temporarily convert it into another shared pointer. To do that conversion, call this lock function. This new shared pointer, which resulted from having locked a weak pointer, has all the abilities of any ordinary shared pointer. It can even outlive the original shared pointer, causing the payload to continue to survive just because of its existence. Just because there may be some weak pointers, by itself, that's not enough to keep a payload alive. For as long as the payload is being jointly owned by at least one shared pointer, then all the associated weak pointers will be able to call lock to access the data. But as soon as that number of shared pointers drops down to 0, then the payload gets immediately deallocated. And when that happens, all associated weak pointers are said to expire. Calling lock on an expired weak pointer doesn't get you access to anything anymore. The language provides this expired query function, which is the same as testing if use_count is now 0.